Hi everyone, we're from Gents, and today's session is basically going to be on reverse engineering and web security. So our speaker here with me is Anirudh Prasad. He is actually from Press University, Ring Road campus. He's currently in his second year, and in fact he's actually working on his own operating system. So he's a member of their CTF team ISFCR PSU, which is currently ranked 10th in India, and he's also participated in bug bounty programs held by Stanford and Cambridge. He's also a certified AppSec practitioner and engages in freelance bug hunting and penetration testing. So we're looking forward to this session a lot, and I'll hand it over to you.
Yeah, I hope you guys can all hear me fine. Okay, cool. I'll just start off, with a small introduction, and I also want to know how much you guys know about web security and reverse engineering. So anyone here who has any prior knowledge with web security? Just let's start with web security. Leave reverse engineering out of the picture. Anybody here who has done anything with web security? They can just raise their hand and tell me what their experience is up till now. Anyone? Okay, no, that's great. So I can teach a lot today. Right. So let's move on. So who am I? Right. So that's my contact. If you want to talk to me, if you have any questions for me, you can just mail me over there. And that's my website. I have other information on there, my GitHub and everything. So you can see, what projects I've done. You can, if you want to collaborate on any projects, you can always mail me. And like I said, ISFCR CTF team. So we were quite active a few months ago, and we did place third all over India, and then we all had exams, so kind of died down a little bit. But we're planning to come back even stronger. So that's that. And yeah, bug hunters. So after my 12th grade, I had a lot of free time, because we were just going to go into college and I really didn't have much to do. So I thought, I'm interested in hacking. Why not try to hack something and get acknowledged for it? Why not do something big? So then that's when I found, there are these bug bounties posted specifically by colleges, right? So bug bounties are naturally a thing, right? It's just there because companies want to secure what web infrastructure they have or what applications they have running on people's desktop clients. Okay, but then the thing is, when colleges ask you to test, you have to know there's not much security in place already, right? Because that's not their prime focus. So that's when you have a good opening. You can kind of start bug hunting and you can explore your what you're good at, your technical fields. So when I started bug hunting Stanford, I started out with simple recon. I found out how many subdomains they have and what platforms they offered. And that's when I found out a few subdomains that were, that lacked security, and then I started individually testing all of them. So I tested for web template injection, cross-site scripting, HTML injection, stuff like that. And that's when I came across a single parameter on a website that was vulnerable to HTML injection. I reported this bug to Stanford, and they acknowledged it. They sent mail back saying, "Thank you for reporting the bug, and we'll fix it." So yeah, that was pretty much the whole story with Stanford. And a similar thing happened with Cambridge. I moved on to trying to attack some other colleges, and I found out Cambridge runs a very vulnerable software on one of their subdomains. And so I exploited that using a known CVE, which we learned later today's session, how to exploit known CVEs on any websites running old software. And so yeah, I got acknowledged by Cambridge too. So yeah, that's about my bug hunting story. After that, yeah, writing my own OS. So this began also a few months ago. It actually began in my first year. That's when I woke up one day. I'm like, what would it be to build your own OS? What would it be like? And so I thought I'd start out with x86, right? So I started out with 32-bit, and now I've moved on to 64-bit. So my operating system is running in 64-bit. I'm currently writing the kernel. And yeah, if you guys if anyone here wants to collaborate, just drop me a mail. We can work on the kernel together for my OS. Yeah, and Socketeer, it's another project I made. So Socketeer is a network penetration testing tool. So you know how there's HTTP and HTTPS, right? So one is secure, the other isn't. That's the simple explanation. So when you connect to a network, any network, if it's an open network and you're browsing, say, a HTTP page, you're going to end up leaving a lot of information to the attackers or anybody who's sitting in the middle running a packet sniffer, right? And it's not that hard really. But the tool that I built, it finds a way to exploit any open network and allow people to run HTTP on it. And no matter what device it is, you can find out the name of the device and you can find out everything that goes between the network switch and the device itself. So it's like a very individual attack, right? It's like Wireshark, but Wireshark, the thing about Wireshark is it captures everything on the network. But socket here, it captures everything for one device and it gives you more information than Wireshark. That's pretty much it. You can use socket here to even like deface websites on the client side. So if they're like browsing on your open network, you can deface the website that they're looking at. So that's another cool thing. Yeah, pen testing my school. So again, when I was in school, I was pretty bored. So I decided, why not hack the school network? And I did it. And then, the school kind of almost kicked me out, but then it was worth it. They acknowledged it, and I could put that on my college application to the US, and I got in. So that's a plus point, I guess. Yeah, and the last thing today that we are actually going to be talking about is reverse engineering games. So I'm pretty sure a lot of you have played games. How many of you here have played Forza Horizon? Any of the titles? Cool. Yeah, so I'll be looking into how you can reverse engineer Forza to get points, get different cars and stuff like that. So yeah, and also by the way, Forza's online, the program that they use for like connecting players between each other, the server program, it's not secure at all. So I'll be talking about that too. Cool. So let's start with web hacking. So like I asked, okay, now that I've spoken a little bit, broken the ice, can anyone tell me what their understanding of web hacking is? Anybody here? Anyone? It's free. Like you can tell me. Okay, fine. Let's do this. Tell me your basic understanding of what the web is as a jumping off point. Anyone here? Anyone?
Network of computers.
Okay, fair enough. So he said network of computers, right? So what do you mean by network of computers? Are you trying to say you have one single computer that connects to multiple other computers? Is that what your idea is? Okay, so fair enough. That is a good answer. You could say the web is kind of like a network of computers, but you have to understand the computers that are there on the web, not all of them are desktop computers. They're not usable like our desktop computers. So most of them are servers. You have DNS servers, right? And so DNS is, it resolves any IP address or whatever you give to it as like any address that you give, it resolves it into an IP address. So you can access these websites without having to remember the exact IP address of it. Right. And this is also helpful when you have mirrors of websites. So you'll have a single website running on multiple IPs. That's called scaling, right? Google obviously doesn't run on a single IP every time, but you can't remember every single IP that Google runs on. So that's why they have a domain name, and that's why there are DNS servers. So the web, as he said, is a connection of multiple computers, right? Now, when you always have a network, there is always a way to exploit these networks. Because if you're not directly connecting some computer to another computer using a wire, which also is exploitable, but for the sake of our simple explanation, anything that's over the network, right? Anything that's not wired, it's easier to hack because you have protocols like sockets, and sockets, well, they come with vulnerabilities built in, right? Because you can mimic sockets, you can mimic IP addresses, stuff like that. So yeah, web hacking is the process of manipulating functionality of a website. So when you take a website, it's running a specific stack, it's running some technologies, right? And each technology, it's been written by a separate person, right? So every JavaScript framework is not written by the same guy. So you'll obviously have certain issues when you try to use these together, right? And that's when an attacker comes in and they say, okay, I'm going to exploit the connection between these two technologies in the stack, right? And also, there's like a web sign up flow. Let's take that for example, and you have to input an account and you have to get an OTP and you have to put that inside a field. What if you can intercept the OTP before it comes to your phone? Right? So your browser, when you input your account details, it sends a request, and the request contains the OTP. Right? Some websites, they don't encrypt it. And what can you do with that? You can grab the OTP and cancel it, and you can input it without the phone. So with this, right, you can create an account with someone else's phone number without them knowing, which is great. I mean, as an attacker. Right? So yeah, you can use it to access privileged information, which is like I said, using someone else's number. Or you can unauthorized accounts, so you can log into someone else's account with like a small change in the token. Right? Some websites use JavaScript tokens, and over there you can change certain parameters. You can brute force the key over there and change the parameter, so you can access someone else's account. So it might be a standardized token for every account, and only like some accounts are like different. Those are like admin accounts, and so the parameter that might change was user type admin, and for the normal users, like user type client. Right? So if you're able to change that and then input that token inside your web request, you'll be able to log into the admin account. So that's accessing unauthorized or privileged information, right? And hidden website features. So I'm pretty sure all of you know how websites work, right? There's like a directory, your link directory on the top, and it accesses different pages, right? And if you're using something like a non-static routing framework, you won't have certain directories, right? Because they'll automatically take you to a root which will display the directories inside it. But some of these websites, like there's this thing called robots.txt. It's there in almost all websites. Right? It gives you certain information for like allowing certain user agents and stuff like that. It's like a rule set. And sometimes the robots.txt might contain certain information that's not supposed to be visible to the user. And a lot of CTF challenges, like a very beginner level ones, they'll give you like navigate to robots.txt and you can find a flag over there. So that's pretty cool. And yeah, of course, changing the website functionality. So PHP, it's not a great language, right, for the web. At least now it's getting a little better, but a few years back it was very bad. So the thing about PHP is certain functions in PHP are absolutely vulnerable, and if you change them, you can change the entire working of the website, how the users are authenticated itself, right? You can change the way the users are authenticated, so you don't even need to be an admin user to get all the access. So that's an important thing, right? So yeah, components of a web attack. So remember when I said I did recon for a while on the Stanford target? That's like a first step, right? So recon is basically you enumerating any details that you can get about your target, right? So there's something called a scope for a web target. So you need to know what you can and cannot attack, right? That's mostly like a bug bounty thing, because you don't want to attack stuff that the company doesn't want you to, and you don't get in trouble. So the scope is something that you have to strictly follow. So when you make a rule set of what you want to attack, you have to just include the scope in there, and you have to start your recon. So the recon, what it does is, so there's something called a star domain, right? A star domain is basically an apex domain, but any subdomain can be attached to it, right? So a.b.c, a.b.com, right? The apex domain is b.com, but you can make a.b.com, then d.b.com. So it doesn't matter. So that's a star domain, right? So if you're being allowed to test on a star domain, you can test on any subdomain that the company has. That's the first thing. Another thing about recon is directory enumeration. This is a little more of a primitive technique because it causes a lot of stress on the server infrastructure, and you wouldn't want that happening to a production environment website. Okay. So I think we would usually skip over that part if you're on a public CTF, if you're on a public CTF, or if you're on any public bug bounty hunting session. But if you want to learn how they work, then you can always spin up your own instance and test it on that. Or your college website. I don't condone it, but yeah. So yeah, so this recon, right, it also lets you find out what technologies the website is using. There are very small tools that allow you to do this automatically from the browser itself. It shows you what stack it's using, which is pretty cool because, like I said about PHP, right? So I found out that PHP has a vulnerability and I exploit it. How do I know it's running PHP? So that's another thing. I need to intercept the request. So what if I don't want to intercept the request? There are small extensions you can use to directly figure out what kind of technologies it's running, right? And that's useful because in a specific CTF I was taking part in, it was using I think Express, right? And it was using a very outdated version of Express where it had vulnerability in one of their request methods. And the solution to the CTF was just find the request method that's vulnerable and send a request to the server, and it'll give you the flag. So it was a very simple solution, but coming to that conclusion, it was hard because you had to know which technology it was using. So that's why recon is very important, right? So yeah, then exploitation. So like I said, after you figure out what it's using, after you figure out what kind of logic the website is using. So for your login, right? So your login functionality, every website won't use the same sort of logic, right? Some websites may authenticate using a token. Some websites may authenticate purely using just your username and password, right? And so when you do exploitation, you need to know what sort of a logic that the web application is itself using, right? So only when you know, it's like you're given a program, right? And it's encrypting some piece of string, and it's doing it in such a way that they're giving you a seed for the encryption, and you need to find out the original text, right? Or you can even take it as a random function. So you guys must know about the random function in Python, right? And how you can give a seed to it. So if you input the seed and you run the random function on the randomized string, you can basically reverse the randomization, and you can get the original string back. So this is kind of like how you deconstruct the logic and go back to the initial string, right? So that's kind of what you do here. Okay. So you find out what logic the website is running and you exploit it, basically. And also, not only this is not only for sign up flows or login flows. This can be for your add to cart stuff, your checkout, where you you make a user perform an action. That's pretty much it. Or you're updating a table, updating a database. So that's one thing. and you have your cross-site scripting or SQL injection. So cross-site scripting, for the uninitiated, is basically when you run a script in a script tag on any parameter on a website. So that can be like a search query also. Right? So there are certain websites which have like a search box, obviously, and you can search to the index of the website. But sometimes there's no proper input sanitization. So what you can do is you can basically put any script inside that, and it will run the script as if it was actually JavaScript, and it won't take it as a search query. Usually what it should do is take it as plain text, right? So that it just runs the query and returns if anything is matching that specific regular expression. But it doesn't do that. So yeah, that is cross-site scripting. SQL injection is somewhat similar. You can also inject it into a search parameter. But the difference is that it doesn't run a script, it doesn't run a JavaScript line. It actually runs SQL commands, right? So you can request data from the table. You can completely delete everything that's there on the table, or you can do some more fun stuff like parse only certain users from the table. Anything that matches admin, you can bring the users and then details back. That's that, right? Then post exploitation. So basically, after exploitation, you need to figure out whether this exploit that you found on the website or any application, if you can replicate it. Right? If it's a one-time luck thing, then it's not really an exploit. Right? It's just like what people would call a big flip. Right? It's just a random occurrence. So post exploitation is when you have to like see if you can use the same payload and you can replicate the attack on any device or any user. Right? So if you can replicate this attack on your own user, right, it's not really useful. You need to be able to do it with any user. Right? So that's one thing. And you should also make sure that, so there's a thing called clickjacking. How many of you guys know about that? Anyone? Okay. So clickjacking is basically embedding a website inside a frame onto another website. Right? And so you can embed this website onto another website and you can make the user click on actions inside the embedded website without them knowing. Right? They think they're on a different website, but then the actions they're performing are on another website. Right? So if they're on my website and I embed Google on it, right? If I embed the Google website, and they can navigate to whatever they want there, and they think that they're all a part of my website, right? And so the way you can exploit this is you can add like a by function, and you can into any website, like whatever website that you want to target, and you can embed that inside your website. And when people think that navigating to your website, they can click on the by function and waste their money, right? Or you can embed your website into someone else's website, which is worse. So this is a fairly decent threat, but the problem is in like today's world, with today's web technologies, it's not really a risk. It's more of just a best practice, because people aren't going to just see an embedded website and click on it randomly because the browser draws everything properly. Right? So we need to make sure the threat that we're discovering, it's not really like some best practice threat. It should be something that we can exploit and that can break the website's code functionality, right? So that's important because if you report something like clickjacking, you're mostly just going to get an informational tag, and they're not going to acknowledge your account. You're not going to pay you anything, which sucks because you spent a lot of time on it. You spent a lot of time hacking the website, and then you're going to end up with that. That's not really fun, is it? So yeah, let's move on. Like I said, right, approaching the target. So in Recon, I told you about apex domains and subdomains, right? So there are certain tools that you can use to brute force these subdomains, right? So these subdomains, for most websites, most like large scale websites, there's like a lot of subdomains. So you can basically run this scanner on any website, get all the subdomains, parse it into a text file, and if you're searching for a specific vulnerability, say you're searching for cross-site scripting alone, you can run that. So you can make a tool, right, in Python or in Go, and you can basically test for cross-site scripting on a single website, and you can modify the tool in such a way that it can take a text file of all the subdomains that you have found, right? So once you parse that, you can basically run this attack on every subdomain. So that will make your attack, your attack strategy much more efficient. You won't have to spend time testing everything manually. So that's the thing, right? Most of the bugs that you find that aren't high value, like cross-site scripting, if that's not stored. So these kind of things, you'll have to automatically test. You have no choice, because if you sit and you can't sit and manually test like 100 subdomains, right? That's impossible. Because you'll have to check each and every subdomain for a parameter, see if it has one, and then inject a payload into it and check for response. So that's why you can use automation tools for these kind of bugs, right? And so the thing is, these kind of like testing methods, they come under your recon itself. They don't come under exploitation, because you don't know whether the cross-site scripting payload will work or not, right? So you're not certain of your exploit. So you just put it under recon, let it run for some time, see what information you get, and then move forward based on that. Right. So low-hanging fruits. So I'll tell you about some more vulnerabilities. So there's this thing called insecure direct object referencing, right? So it's when you send a request to a website and it gives you a response with whatever details the user has, right? Obviously, because your user has like certain, fields, your username, password, how long ago the account was created, and stuff like that. So your insecure direct object reference, or IDOS for short, you can modify these parameters and you can send the request back. And so what this does is you can log into different accounts, right? So you can change your username or you can change your user ID. And you can even do the same thing with forgot passwords. So if there's a vulnerable forgot password link, basically which means that you give forgot password and it sends a link to your mail ID. And the link contains the original link of the website, / forgot password, / and then some sort of a small UID, like a unique ID. But then the problem is this UID sometimes it just may be easily brute forceable, or it just may directly reference to the user. So it'll be like, it'll not give a UID in some cases, it'll just give user equal to something. So if you're able to change that user to your name, or if you're able to change the user to someone else's name, you can basically make a forgot password link for their user. And you can access it, change the password, and log in. So that's what insecure direct object reference. So these are like low-hanging fruits. Right? These are like, it's like easy to exploit, but they're not easy to come by. Right? So if you're like pen testing a web application and you want to find some bugs quickly, you could technically test for something like IDOR, but it's harder to come by. But when you do, right, changing a parameter isn't going to take that much time. There's no logic flow that you have to check for. It's purely just scanning what request is being sent and modifying that according to what you want. So yeah, that's that. So like I said, scope and stack. So what are the possible points of attack? When you enumerate, you need to know where to attack and what to attack, right? And stack. Stack is basically, like I said, you have a tech stack. Like if you have PHP, then you know what to attack. If you have Express, you'll know what kind of attack vectors are possible. So there's this thing called CV, like I said, it's like an online database of all the exploits that have been discovered till now. So what you can do with that is, you can search, the technology that you're trying to exploit, space CV, and it'll just show you a list of every time this technology has been exploited before. This is kind of what I did for Cambridge. I just searched, what technology they were using, and just searched for CV, and I found like a bunch of exploitable versions. And cross-check with the version that's running on the website, see if it's the same, and then you can possibly exploit it, right? So, and there's like good documentation on websites like ExploitDB, where you can see how to exploit it exactly. They have given like full guides on what command you can use and like how to approach the target, how to modify the request and stuff like that. So yeah. So broken access control. So broken access control is where you can check for directory enumeration, right? You can access certain parts of the website without having admin rights. That's broken access control. I've already told you about XSS, SQLi, and server misconfigs. And server misconfig is pretty much similar to your stack vulnerabilities, where you have an outdated version. That's your server misconfig. And then broken authentication, that's obviously your sign-up flow, your logic for your login for every user. And your forgot password also comes under broken authentication. So yeah. Right, so let's move on to OWASP Top 10. So OWASP Top 10 is like, it's like a guide for all penetration testers, right? And so like I just named a few vulnerabilities now. A few of them are part of OWASP. So it's basically like a top 10 list of what are the most critical bounties, or what are the most critical vulnerabilities that you have to search for on a web application, right? So like in most bug bounty platforms, they most of the time give you like a list, what is the highest paying bug, lowest paying bug, and that'll be mostly based on your OWASP, right? And yeah, you can use them as like when if you're doing something like a CTF, right? And you're completely unsure of what they're asking you to look for, and it's not like a hard challenge, it's like a medium challenge. You can be sure that they've asked something from OWASP, like you can test for all the 10 possibilities in OWASP, but it won't be the case mostly because they'll give you clues. But if it's not there and you're like completely lost, you can try OWASP, right? And yeah, are they actually that common? Some of them are, some of them aren't. Like cross-site scripting, they're not that common these days. They only happen on very secluded subdomains. Yeah, I will show that a bit later. Yeah. So I'll tell you about RC, right? So RC is remote code execution. I'm pretty sure quite a few of you here would have heard of log4j, the vulnerability in Java. So that's RC, right? It's like it was a Java library. It was used in Minecraft and this popular reverse engineering tool called Ghidra. And basically, you can execute code remotely on the machine that this software is running on. So say your Minecraft server was running on some server on Linode somewhere outside the country, and you're playing on a server like that, and you run this exploit in the chat. You can basically get access to the shell that they're running. So you can look through the system through the command line with just like one exploit. Right, so that's RC, remote code execution. And yeah, we look at an RC CTF today, and I'll just show the demo for that. And yeah, payload injection, SQLi, SSTI, SQL, and cross-site scripting. So basically, a payload injection is you craft something to perform an action on site on the website itself instead of on the client side. So that's payload injection. Request and response manipulation. So everything that I talked about, IDOT and stuff like that, those are request and response manipulation. Sometimes you can even change the headers. So the website headers may have like a specific location that you're coming from. You can change that location, where you're coming from. You can change the browser that you're using. Some websites that may be like invite only, let's just say, okay? They might accept requests only from a specific browser that they have created themselves, right? And you have no way of accessing, you just know what browser it is, right? So say there's like this secret company, okay, and they want to make a website for their employees, and they can access it only through the browser that was built in-house. Nobody has access to it. It's closed source software. How are you going to do this? If it's not protected well, you can just change the browser name and you can log in through that, right? So there is a list online of what are the popular and valid headers that you can use inside a request. And yeah, broken authentication. I told you about JavaScript tokens. So they're called JWTs, JavaScript Web Token. So basically they come with encryption, right? So it's not really that easy to exploit, but sometimes the encryption will be weak. They'll use like a weak key. And you can basically decrypt it and you can change what parameters there are inside that key, inside the token, right? And the token will give you access to like different types of users, stuff like that. And the current user scope. So current user scope is basically what the user can and cannot do with this account, their privilege level, right? So if the user has like a normal, like a tier 1 user level account, right? And they just signed up, they'll have less privileges than someone who's been on the site for, say, more than 10 hours, because that will be the requirement. So someone who's on the site for 5 minutes can't perform certain actions, right? Someone who's been on the site for 10 hours can do it. So you can bypass that stuff with broken authentication. You can, in some really poorly built websites, you can also bypass, like, the premium check. There are like these online websites where you can, you can task it to write an essay for you and stuff like that, and it won't let you go over a certain number of words. You can bypass that with just broken authentication. You can change parameters in the web token and stuff like that. And yeah, they're mostly related to cookies, browser cookies that store information about the user. So that's like an important exploit. So yeah, so I just kept talking about requests for so long. I'll show you guys what a request actually looks like. So I'm trying to visit the TryHackMe website, right? Also about TryHackMe, it's a cool place where you can go and learn hacking on your own. There's like roadmaps, they'll teach you like what to learn next, and they'll like give you challenges to solve. So you guys should also check that out. Right, so request. This is your header, almost all of this. See the email part here, I don't know if you guys can see it, but yeah. So this part says email, right? So that's giving my email, password. It shows my password in clear text, right? So that is when I'm logging in. So this is the details that I have sent to the server, right? And this is my details that I have not sent, but it has automatically picked up from my client. So that is important, right? Because when we do certain attack, we'll be manipulating these headers, right? And another thing is, you can also intercept the response from this. So when you send a request, your request is not valid, right? You give the wrong password. So in certain websites that obviously aren't very well, what you can do is, you can intercept the response, and in the response, if you get an error code, right, you can change that error code to 200 OK, because that is your code for accept, and just forward the response, and you'll be able to log in, right? So it's things like this that you have to see inside a request, where you can modify certain parameters and get into the website. So yeah, tools, right? So the screenshot that I just showed you, that's a tool called Verb Suite. So it's like a software written in Java. You use it to intercept web requests, right? And like I said, you can check also the response and modify that later. So yeah, you have to basically check every parameter inside your request. There are obviously tools to do this, but you can basically most of the times get away with just looking at the headers, right? So the header, obviously, like in this website, there's not much. I'll show you an example what I mean by like the header is important. You will have something like X powered by, right? And that just shows you what technology stack it's using or what is the main backend that it's using. And when you know that, you can pretty much just look for exploits or like see if it's been broken into before, right? And yeah, and even here, say you're doing a password reset exploit, right? And you send the request for your password reset, and it comes with this. And when you're sending the request, the email that you've given for the password request, so you give your email. Sometimes what you can do is, and this is actually a pretty recent exploit in a few websites, you can just add a comma and you can put a different email ID there. So you can request a password reset for someone else's mail and just add your mail ID there with a comma. So it sends the password reset link to your mail and their mail. And if you're the first one to access it, you can get access to their entire account, which is cool. So yeah, Burp Suite, I just told you about it. Common solutions, I also touched upon that with the password reset thing. So basically changing parameters and stuff like that, looking for outdated software, and even WordPress. There's this really good tool that someone made for WordPress. It's called WordPress Scanner. It constantly updates itself with the new database of exploited WordPress versions. And when you run the tool on some sort of a website that's running in WordPress, you can find out whether it's been exploited, whether that version is up to date, whether any plugins that are running on that WordPress website is up to date or not. Those are exploitable. You can go through that too. Yeah. Like I said, TryHackMe, good place. Does roadmaps and stuff. You can pretty much you can learn all of web hacking from there if you want to. But I also recommend Portswigger. It's a very cool place where they have labs you can test on directly. And Portswigger is the company that made Burp Suite, the software I just showed. And then you have EcoCTF. This one was made by CMU, and they have a pretty cool repository of challenges. It goes from hard, easy to hard, and basically they give you a platform where you can choose any challenge. There's a small box to input the flag that you obtain. You can start instances, so you can say I want to work on this now. Start an instance for 30 minutes. That server will be up and running. So it's all yours to test. There'll be no one else testing that. So yeah, that's pretty useful also. And Hack the Box. Hack the Box is a bit harder than the other two, I'd say. But yeah, you should give that a go also, because the thing about Hack the Box is it has a lot more competitiveness. There are people trying to get Hack the Box top 1% and stuff like that. I've never really got into that, but yeah, it's available. Yeah, so real world CTFs. So at PES, we host quite a few CTFs. Next month we're going to host a bunch. You guys, if you want to learn more, it's always best to go to real world events, right? Real world CTFs. You'll meet people there. There'll also be knowledgeable people over there, and you'll never know. You'll probably be sitting next to the guy who's going to come first in the event. So try going to real CTFs, meet people, and learn from them. Because I personally think that's the best way to learn. Is take from others. Because there's a few things that come with experience that you just cannot find in a book, right? So someone might just it just might not be documented well in a book. And someone might be okay, I figured this out on my own, I can help you. So it saves you that time of having to figure everything out yourself, right? You can spend time on something that you're more interested in and figure that out, right? And you can ask someone else, have you done this exploit before? I'm not able to do it through the documentation. And that's why, meeting people in real life in these events is helpful. And speaking of real life, also try bug bounties. Great place to learn. There's no repercussions, obviously, because if you don't have them, they can't really sue you. So there's no problem with that. And if you do have them, they can give you money, so don't worry about it. Try real world bug bounties, they're really cool. There are two websites that are main websites called Bug Crowd and HackerOne. You should try those websites out. I'd say start with Bug Crowd if anybody here wants to do bug bounties. They're a little more easy on you, and you get good invites to private programs. And yeah, so yeah, recon tools. So I told you about Burp Suite and OWASP. OWASP is pretty much the same as Burp Suite. Intercept requests and stuff like that. Nuclei is this pen testing framework that you can run from your terminal itself, so from the command line, and it lets you do enumeration stuff. So you can find subdomains, you can find parameters, you can find template injection parameters and stuff like that, which is very useful because it saves you a lot of time. And of course, browser dev tools. Never forget this. Even I use this pretty often. I don't want to obviously open a heavy Java application every time I want to check some request. And so this is very helpful. I'd say use the Chrome web tools because they're a little better from my experience, even though I use only Firefox. But yeah, Chrome web tools are really good. You should check them out. And use Chromium because it's open source. Yeah. So I told you about HackerOne, right? So this is basically what one of their web pages, right? It's called Hacktivity. It shows what websites have been exploited recently. Right? This was like 10 years ago. Right? So someone found a vulnerability on LinkedIn, and basically it shows an active list of what has been exploited in the past few hours, and you can see even what's been exploited years ago. And this gives you a good insight because a lot of people when they get into web hacking and stuff, they're like, oh yeah, definitely not going to find cross-site scripting on such a famous website. But then when they go here, they're like, oh wait, someone found cross-site scripting on Snapchat, and then they go crazy. They're like, wait, I should have done that. It was so easy, but I didn't do it. Right? So this saves a lot of the time on that kind of thinking attitude. Because you're gonna realize a lot of companies actually don't put that much effort into their security. That's why they're here on these websites in the first place. So yeah, that's pretty cool. You can even see Uber got exploited 18 hours ago. So yeah, that's pretty cool. And all the way there, the picture on the top, that's the other website I was talking about, BugCrowd. You can see pretty famous companies offer for you to go and test their platform. So that's also there. And this last one, it's pretty cool. I don't know, actually you guys might know this because it's pretty famous. It's called Have I Been Pwned? Basically what it is it's like a database. It's like a web database where if you put your mail ID, it'll tell you if you have been found in any data breach in the past. Right? So you see all these companies getting hacked here. You might think, okay, Uber, I have an account there. What if my details are out in the dark web? So you can use that to check. You can input your mail ID, anything that you've used in the past, and you can just check. It'll give you a list of all the websites you've been found in, what repositories you've been found in, and it even scans for the dark web, which is pretty cool. So yeah, let's take a look at an example. So just give me a second and set it up. So this is Burp Suite, right? And I've set up this website.
No problem.
Okay. Yeah. Bog standard website. Welcome Agent Smith, right? So let's just explore this. Let's see if there's anything out of the ordinary, right? There's a link here. Okay. It's Agent Smith from the Matrix. Right? So yeah, pretty standard is just an image. And if you go to your mission, let's see what that does. If it goes, okay, it takes you to Big Chilling. John Cena singing Big Chilling, right? So yeah, pretty standard website, has a funny video, but let's see what's actually going on under the hood, right? So if we put this on and we reload the website, see we get a hit over here. What you're requesting to the server. So get means you're obviously trying to obtain something from the server and you're getting these details, right? And so if we forward this, it'll just load the website. That's it. So it's a very simple website from the looks of it. Now let's reload this website. Let's right click it and do intercept response to this request. Okay. And then so we get a response, and this response basically contains the code for the website, right? Also pretty standard. You can even just do inspect element and find it. What's the big deal, right? Here's the thing. On the top, if you can see this part, X powered by PHP 8.1.0, right? So now when you're in the game for a long enough time, you will know that this version of PHP is actually exploitable. It had a backdoor in it, right? Yeah. So it's RC, like I just told you. This is an example for RC, remote code execution. So you can actually just look it up, right now on your laptops if you have internet, just look up PHP 8.1.0 CVE. Right? You'll find some backdoor RC exploit that it had a few versions ago. Yeah. Anybody just tell me if they found it? They can see it. You got it? Yeah. So that's the thing, right? Once you know that it's running an exploited version and it has a backdoor, you can do pretty cool stuff with it. So I'll just show you. Right. So there's a thing called curl. Right. So what curl does is it obtains. You can input a URL and it obtains all the information from it. So it essentially does what Burp Suite does, but then instead of like using a heavy Java program, you can do it from the terminal, which I think is more elegant. So I've actually set up this command before. So yeah, let me increase the size. Just give me a second. Yeah. Can you guys see it? Okay, so you will see it down here. So yeah, if you guys found out the thing that I was just asking you to, you would have found something called user agent keys, right? So that's the exploit. That's the backdoor that they found, and it was sold to zero-day system, right? And so what it does is it gives you a reverse shell, a temporary reverse shell, which is what remote code execution is basically. You can execute code on the side of the server, right? And so inside the server, say this. So if you're doing a CTF and you have something like a flag, you just give it a flag.txt. So you can just do this. So I'll show you. Do you guys know what cat does in Linux?
Cat is to bring
Yeah.
out to the program.
Yeah, so it concatenates basically. If you give, if there's a file, text file or a markdown file, or actually any file for that matter, I'm just giving examples of readable ones, but even if you concatenate an exe file, it will show you the bytes, but there will be nothing to read. So if you cat a text file, it will show you the contents of that text file inside your terminal itself. So you don't need to open it with the text editor. So what I'm doing here is, I'm giving the zero-day system prompt, and inside the parameters for it, I'm just giving it the command that I want to execute, right, which is cat flag.txt. So if I run this, it will take some time, and it will show me. Okay, it's being cut out by the projector, but that's fine. It shows this, which did not show in our request when we sent it to Burp Suite. Our Burp Suite request just showed this part. This is the flag, and then this is whatever top secret stuff they have on the server. Then I can execute any code within this. If I do just ls within this, it will just list the contents of that server, right? Whatever's in that current directory that the website is running. So yeah, that's pretty much it, right? That's like your RC. Given a website, you have to look at what technologies it's using, and then you can just exploit it. That's pretty much it. So yeah, you guys have any questions regarding this? I can answer right now. It's not an issue. Anything? Anybody doesn't understand anything about it? That's fine. I can just give it a rundown again of what we did. But essentially, figure out what technology is running. If in this specific example, we found out that it's running something that has been exploited before, check how to exploit it. And if you go to the CVE website, you can also find that it's giving a direct explanation of how to do the RC. Right? It'll show you how to input the command and what user agent you use. So get that and then put it into curl. You can even do it inside Burp Suite, but I prefer this. Put it into curl. You'll get the code of the website along with whatever command, the output of whatever command that you've given. That's pretty much RC for you. You can even do this with a log4j. Pretty similar. What you would do is you'll get a small. So once you run the exploit, and once you run the POC or proof of concept, you get like a small string, and you just input that string into any vulnerable text field that is running log4j, right? The specific version. So that could be a Minecraft server or Keyra, like I said. Some websites too were running this, and it was exploited the height of log4j's popularity. And so yeah, you will get a shell like that is more than RC. That is more of a shell. So you can actually just do. So you can do bin sh. Right. Bin sh is basically activating a current shell inside the terminal. I'll show that too after this in our reverse engineering thing. So yeah, that's pretty much how you exploit with RC. I guess that's it for the demo for this. We can move on to reverse engineering unless you guys have any questions as well. Anyone, anything? Cool. Okay, reverse engineering. Right, so let's start with analysis, right? So before we actually do this, I'll explain to you what reverse engineering is. Because it's a pretty broad term. I even mentioned we can use reverse engineering inside our web application for the logic and stuff. So reverse engineering mainly, at least the CTF category, it pertains to reverse engineering binaries, right? And binaries are basically what you would call an exe file on Windows. Right? So these files, you can execute them on Linux with just a single command, and you can't see the code behind it. So when you open it, it'll just be like a bunch of bytes. So you can't actually see what it's running. You can't see the logic behind it. So what you do in these situations is you have to run it, and then you have to try put in whatever input you can to see if you can break this program, right? And that method of testing is called fuzzing, right? So fuzzing is when you just put any input you can, any input you can think of in any range. So if you put like 1A and it gives you an input, it gives you an output. you put like 10 Ks and see what it does. Does it set fault? Does it buffer overflow? You have to see these kind of things, right? And so that will give you more insight. So yeah, so analysis. So this part, right, the analysis part, it's where you try to find out the logic without doing fuzzing, right? So you can't fuzz, you can't check the output, right? So when you have these kind of situations, you basically disassemble the program. So disassembling meaning you have the binary, you can use certain tools to read the assembly that it's using, right? Or any function call that it's making. So sometimes there will be a function called flag, right? And flag will just return the flag to you. And there will be some function calls that just say win. And then if you reach that function or if you return that function, you'll win the challenge, right? So it's stuff like this. And sometimes it'll just be a specific address or a specific value, right? If you're looking for a value of a certain item inside an application, right? You can search for that value inside the disassembly and you can try to return that function. So if I, like I said, Forza, right? If I want a specific car, I look for the value of that car. There'll be a table online or there'll be something that you can find out where you can see the hex values of every car. Search for that value and then just return that function. You can get the car for free. Stuff like that. I'll show you how that works. So that's analysis, right? Then you have exploitation. So once you figure out how the functions are working and which function you have to jump to, you can exploit them by just actually making a payload to return that function every time. So if it's a buffer overflow, you can just add the exact number of bytes you need to overflow the program and then return the function that you need. So if it's a when function, you just return that function. That's it. So that's exploitation. Okay. So popular tools, I told you about Ghidra and how it was, it fell under the attack of log4j. But actually Ghidra is a pretty good tool for reverse engineering because it can do disassembly, right? You can find out the assembly that's running behind the program. And it's free, and it was a tool by the NSA. So it's pretty cool. And then you have IDA Pro. It's paid. It's also pretty useful, but I prefer the last one there. It's called Redire. It comes standard issue with like almost all the penetration testing Linux distros, and it runs inside the terminal, which is great. So yeah. Great. So like I said, binaries without any source code. So you get a program. So you have a desktop application, right? Like Spotify, right? And you just want to know what it does in the backend. You want to know how it works, or you want to see what sort of calls it's making to serve you ads, so that you can then remove these ads, hypothetically speaking. So then what you can do is you can disassemble the program, right? And you can see what calls it's making. So that's when you would use reverse engineering. Right? And then server-side applications. Like I said, you have your web application that I said you would need to use reverse engineering there. So the logic for the website login and stuff like that. Reverse engineering is great for those kind of things. So you can trace back from where it's starting and where it's ending. Malware analysis. So do you guys know about WannaCry, the ransomware that hit the NHS? Right. So WannaCry was actually stopped by this guy called Marcus Hutchins. He was just a random, malware developer or security researcher, I would say. And then they threw him in jail, but that's a different story. Poor guy. But yeah, so what he did was he found a kill switch inside the encryptor, right? And basically, that's why you would need reverse engineering, because you don't get the source code of the ransomware. Obviously, the guy won't just tell you, okay, here's the source code, but we're going to encrypt your computer, right? Because that defeats the purpose. So if you get some program like that, you can analyze it and you can find out what kind of calls it's making again. And you can see, like, what this guy did was he found out that it was making a call to a website as a kill switch. And if that website was a registered domain, it would stop the malware, right? So yeah, that is pretty important because you never know when you might save the world. And then computer networks, obviously. Like you said, computer networks is just a connection of computers. So you can also reverse engineer the connections between two computers to figure out where it is located, as in like if you have a specific IP address, it's serially allocated, right? So you can figure out which kind of device it is and stuff like that just using reverse engineering, where the connection is coming from, stuff like that. Okay. So you guys must know C, right? All of you? Okay, a little bit, yeah, that's fine. So you need to know how functions work. I don't think you really need C for that. You need to know how Python functions work, that's fine. Memory allocation, some of this, you need to know C for this. But just very basic understanding. You don't need to have an in-depth understanding, right? And okay, assembly, obviously, not a lot of people are going to know this, but I will touch upon this. And yeah, like I said, C program. So you need to know how to use C. at least a little bit, or at least read C. I think that's a more accurate explanation. You need to know how to read C code to check for logic flows. Right? So yeah, let's start with assembly of ELF. Okay. So I'll touch upon like just basics of assembly. All the components of what it is. What is an ELF file? Like I said, you have executables in Windows, you have ELFs and stuff in Linux. And now how you can read the ELF. Obviously, ELF is just going to be raw bytes, right? So we have to find a way to disassemble this and read. So yeah, you have a basic rundown. So registers, right? These are like memory storage locations predefined inside your architecture, right? So this is kind of like for 32 bits. It's showing you what registers there are. Okay, let's just see it. So yeah, these are like pre-allocated. Right? So they're just memory storage locations, and you can move the memory around these places. So you can perform operations. Then you have instructions. Like I said, you have to move the memory around, right? And you also have to perform operations. So how do you do that? By just having registers. You need certain quote-unquote commands to do these operations. So that's what instructions are. So instructions will be like move. So you can move the memory from one address to the other. And then control flow. These are actually very important for reverse engineering. So something like a jump. Right? A jump is basically a jumping from one function or the execution point of one function to the other. And there are some stuff like conditional jumps. So there's something called JNE. So it's jump if not equal to. Right? So if you're meeting a condition, then jump. Basically, right? That's how it is. And that's very important because in these programs that you see when you're reverse engineering, they usually obfuscate the function. You don't put it in the same order, right? So you need to know constantly where each function is jumping to find out the when function. Then memory and data movement, yeah. Like I said, you need to move it between your addresses, and so basically you have your push pop, which is like stack operations, because the whole thing runs on stack, and then move, and that's pretty much it. Yeah, let's do this. ELF file. So yeah, executable linkable format file. Right? So that's what ELF stands for, executable linkable format. And so basically, you can run the file just using like a / on Linux. And so basically, when you are doing these challenges, you mostly get ELF files because they're the most common and they're the easiest to reverse engineer in CTFs. Right? And then you also have PE files, which are basically exe files or DLL files on Windows side. Right? And how to read it? So basically, you have tools that help you read stuff inside Linux. So there's something called readelf, where you can just see the entire disassembly and every function that is calling. You can pass that into a text file and you can find out what everything is doing. And you can search for functions inside that tool. So you can give a keyword search for win, and you can see if it exists inside this. Or you can give a keyword search for flag. And when stuff like that exists, it's very easy to exploit. Because usually they won't do this. But then if you have like a win function, you just do search for win. It'll give you the address of that function. So you can just jump there directly in your payload, which is very important for reverse engineering. How to identify it? Okay, fine. So if you open it in a text editor, it will show ELF on the top, obviously. But then if you don't want to do that, just do file, space, name of the file. You see here, it just gives you ELF64-bit. Right. And it also gives you some information like whether it's statically linked or dynamically linked. So that's important, the file command. So that's pretty much it. This is what your readelf output looks like. You can see like it's giving you like functions and what everything does. And it's showing you like what common libraries that the program is using without having to look at the code. That's very useful. Right. So R2, I will show you how R2 works right now. Ghidra is like, the one good thing about Ghidra is it will automatically do the analysis for you in some cases, and it's pretty easy to like find stuff using that. And then you have file recon, like I said, using the file command, you can find out whether it's statically or dynamically linked. And you can also use certain other tools to see what libraries it's using, like readelf. And then GDB, obviously, GNU debugger, and fuzzing techniques. Like I said in the beginning, right, you can use fuzzing techniques to find vulnerabilities and stuff. It's not really like easy because you have to spend a lot of time checking any random input and seeing like which input gives which output. But yeah, it's still a valid method. If you have run out of all your options or you don't know how to use a specific tool, just start inputting random characters, just like spam bunch of A's into the input stream, see what it returns. That's how some of the easier CTFs are won. Because sometimes they'll give you some sort of like a program where you just have to they just say reverse engineer this, find the flag. And if it's like in the easy category, just spam a bunch of A's. If it gives you a set fault, then reduce it and just try it again, right? And it'll usually give you the flag. Like it happened to me once. So I was in a CTF, I was doing it and I was trying to disassemble everything. I closed the disassembly, I was like, wait, let me just try fuzzing. I put a bunch of A's, I got the flag. It was so simple, right? But then I didn't think of it. So just look out for those kind of things where you just do fuzzing and you will get the flag pretty simply instead of going through all these steps. So yeah, WannaCry. So like I said, right, there was a check inside the code for WannaCry, and obviously you can't find that using the source code because there's no source code. So when you disassemble, you'll find there's a link, right? And what the software basically did, the ransomware, it checked if this link was active, if the domain was registered. So when you don't register a domain, usually it's dead. When you try to access that website, it just doesn't work. Right? So what this thing was doing is the kill switch. If the malware is still running, that means the website has not been activated. Right? And so what Marcus Hutchins did was he reverse engineered, just found out that this link existed, went and registered the domain and saw what happened. And then boom, it stopped. It stopped, running on every device, and none of the devices were encrypted anymore. They could just access their files as usual. So yeah, that's pretty cool, come to think of it. And also, yeah, what do they use to analyze redraft? Like I said, it's one of the best softwares. You can use that to analyze pretty much any binary. And Marcus Hutchins, you guys know about it. He runs a YouTube channel and like a Discord, so you should check it out. He has like great advice on security. So yeah, coming to games. So I don't know how many of you guys know this. This is actually cheating, if you guys have seen this before. So it's a program that lets you, I found it easier on Windows, that it lets you see the memory dump of everything. I think yeah. So this is what it looks like fully. So essentially, like, this gives you like what values each address is using. So what I did was I was playing Forza with my friends, and I always had like a really bad car, so I would always lose. Or maybe it was a skill issue, but who knows, right? So I decided, I want a fast car so I can beat them like every time we race. So I went to search what's the fastest car, and then I was disappointed because the fastest car was a seasonal drop. I couldn't even get it, even if I got free cash in the game. So then I decided, okay, how do I get this? I went and found there's a table of all the hex values for every car. You go there, there's like an about in the store. It was like cheap. I just replaced the value with the value of the Ferrari as it was on, which was the fastest car. And then I hit buy. 2 seconds later, I had the fastest car in the game, which was a seasonal drop, and it was in my inventory. And then I took the car out, and they were like, wait, how do you have this car? Which is crazy, right? So yeah, that's pretty much reverse engineering games. And like, when I first found this out, it was actually before I wanted the fastest car. Again, I had a different skill issue before this, where I couldn't play with them because I had lower points. So I just made like new points in the game. So this influence points in the game where you just break a board and you get like more influence and you can move to the next season. What I did was I just found like a 5,000 board where you would smash it and you get a 5,000 influence points. I just changed it to 30,000, smashed it, and the game crashed. But then I logged on back in, and then I got the points, which was great because then I could play with them and I could subvert another skill issue of mine. But yeah, so let's look at an example next. So I'll just set it up. So I have another laptop here. It's a separate machine. It's running some vulnerable software. Okay, if I can just turn this on. So I let it turn on. It's pretty slow. It's pretty old. So yeah, I have the software here. Okay, and let's just. Okay, so it's running on this. The software is running on that laptop. Okay, and so basically. So yeah, I did read on the program, and I can see basically the disassembly of this entire thing. I can search for functions, and you see here, if you can see what I've highlighted here, it says win over here. That's one function that you have to keep an eye out for, and even gives you the address of that, right? So now you know where your win function is and which address it's in, and how you can reach that. So there's a thing called bone tools in Python, which you can basically use to run exploits on any binary. Right? You can push it into the input stream, and it will give you the output. Right. So if I okay, I'll just show you the exploit. I'll run the program first. So yeah, simple text prompt. Okay, it just asks you for any input, and if you just give yes, you failed, right? And then again, if you just run it and give end, again it says you failed. So yeah, looks like it does nothing, right? And it seems pretty impossible to get the flag. But then when you run the exploit, I got shell on that machine. So if I ls here, I can see the contents of that machine. I can even find the original source code of this program, and it's running everything from here. So I exploited what's the program that. So I have a copy of the program that's running here over here, right? So say it's like a public release program. So I gave the example of Spotify. Let's stick with that. So it's running Spotify there. It's connected to the internet because it needs to stream songs. I have the same application here because I just downloaded it from Spotify's website. And then I exploit it, and then I run the same exploit on like a socket that this machine is running on. I can get a shell on that if it's vulnerable, right? And this program is. So then I can do whatever I want. I can just do cat flag.txt. See, I got the flag down there. So you can basically, once you get shelled into a computer, you can do pretty much anything with it, right? And I'll show you the exploit right now. It's pretty much it. So you're importing porn, obviously. It's like a pretty good library you can use for like putting it into the input stream, like getting videos into the input stream. And basically, you're seeing how much your address requires, right? So your offset, that's what your offset is. And so you're multiplying any random character by the offset because you have to. Because when you're inputting something, you need to multiply by the offset so that you can buffer overflow it, right? And so once you buffer overflow it, you have to return your win function, right? Because after you buffer overflow it, the program will do what you want. So you need to return that win function because you already found out the win function is what houses your shell, right? And so go back up. Yeah. So here you're getting the executable. You're checking for the vulnerability inside the local copy of that executable itself, and then you're giving it, what kind of a file it is, and then you're giving it else. So there's a thing called ROP. Okay, ROP stands for return-oriented programming. Right. So essentially, it's like a type of penetration testing ideology where you just return a function that houses your solution. So yeah, that's kind of the philosophy that's on this program. And here I'm just connecting to the IP address of that machine over there. So it's connected to my phone's hotspot, that machine. And so that's the IP of that machine on that. On the hotspot, and that's the port I'm running this program in. So the program inside the laptop here, it's running on 1337. So I connected there, and then I send the payload through the I/O. So the I/O is this, and sendLine basically just passes the entire payload, flattens it, and sends it through the input-output stream. And then once I do that, if I get a success, if it returns a win function, I've given I/O interactive. Because if it doesn't return, then it'll just close the program. I/O interactive just gives me a shell. So yeah, so because I put I/O interactive, it gives me a shell over there at the bottom. So then I can just do ls and stuff like that. If that was running something like a sockets program, which was not running inside of shell specifically, I could even launch like GUI applications from it. So I could just type xcalc, or I could type Firefox, and it will launch Firefox on that computer. So yeah, it's it's pretty cool. But the goal is once you get into a system, you should like stay unknown. You shouldn't like pop up random applications so that they just find out. And the coolest thing about this is once you're into the shell, right, you can basically FTP or write any other program that gives you persistence. So that once they finish their work and they reboot, you'll still be on their shell. So every time the computer turns on and like sends a connection request to the network, your computer will pick it up and you can restart the shell over there. So they can never get rid of your program unless they try to find the exact PID, which they won't be able to because they get randomized PID, stuff like that. So yeah, that's the demo for reverse engineering. Yeah, that's pretty much it. So if you guys have any questions, you can ask me now about anything. Anyone?
How do we know which games we can crack?
Yeah. So the thing is, you have to kind of look into every game. Like even Counter-Strike, when I used to play Counter-Strike, Global Offensive, I used to look through the cheat engine time and again, to see how Valve has patched the cheating exploits. And there used to be a way to constantly move your player model around so that you'll never get attacked by the enemy. So your player model will be looking to the front, like according to the enemy, but you'll actually be facing the side. So they shoot here, it'll just not hit you. It'll just like go through you, the bullet. So cool stuff like this, but like you have to keep looking at the cheat engine because they patch it pretty frequently. So yeah, it's just a kind of like a trial and error when it comes to what games you can and cannot hack because you don't know, so you have to keep testing. It's the same thing, what websites can you hack or cannot hack. You never know, right? You have to just test and find out. So yeah, trial and error. Anything else?
Can you use reverse engineering to reconstruct software?
Yeah, you can. So games are cracked, or any software is cracked. They use reverse engineering. So I'll concede. Okay, maybe I shouldn't, but the software I'm using, the Verb Suite software, it's not really the one that I paid for because I'm not using the official one because it has been cracked. So yeah, this is the full version which hasn't been paid for by me. But yeah, cool things like this, you can figure out like what the key generator is doing, where it's making a call, which website is it trying to authenticate your key from, and you can modify this. Once you modify it, you can input any key and it'll accept it. Or you can find out how the key is being generated. If you know the logic by which the key is generated, right, you can just write the program yourself again and then just use that key for this software, and then you can get access to the full version. So stuff like that. So yeah, reverse engineering is pretty useful even then. Good question. Yeah. Anyone else? Any questions? No? Cool. Okay. Thanks, man. Yeah, keep pushing. Remember, hack the planet. It's free for you. You test everything. If you can hack something, do it. Nobody's stopping you except people who are into legal. But you can deal with them later because you can tell them I found a security flaw in your system, so you should be paying me, right? And yeah, that's where the incentive comes from for most people. Personally, for me, it's just the thrill of hacking stuff. It's way more fun than the money. But yeah, do good, learn stuff, and yeah, if you want to ask me anything, anytime, my mail ID is there. If you guys want it, I can show it to you again. Yeah, my mail ID. Anybody wants to ask me anything, any free time you guys have, you want to collaborate on something, just let me know. I'll be there. Yeah, that's pretty much it, guys. So yeah, thanks for coming.